Hey everybody, this is Larry, this is me going Q4 of the weekly contest 372. Find building where Alice and Bob can meet. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem. Or this poem, Q4. Yeah, Q4. So I did this poem two different ways. The one way that I did during the virtual contest, I'm not gonna lie, I did it with a hammer of segment tree. The idea being that the idea being that for each query, you're basically trying to figure out. Let me actually maybe bring up some drawing things, right? Hang on. For this particular problem, and this will come up in a number of ways, but basically, you have some. You have some number of buildings, whatever, they're pretended next to each other and so forth, right? And basically for each query, you're just trying to get the next number that is bigger than both or to some degree, there's some edge cases, but bigger than both the numbers, right? And yeah, so basically, for example, if this is your A, sorry, finger drawing, and this is your B, the way that I think about with the segment tree, and we're not gonna go, this is a way brief going over because there's a better solution. But I just want to go over what I did during the contest, and this is what I did. And so yeah, you have A and B, and then the idea is that, okay, well, if we're able to get max of a range, then we can just say, okay, well, let's say this is the range, and the entire range is going to be, all the numbers, right? Yeah. All right, let me actually use the line. Sorry, friends. So yeah, so this is your range. Let's say it keeps going for a little bit more. I'll draw a couple more boxes, I guess. Right. So let's say your A and B are here. Then now this is just a binary search. If you're able to get a max in reasonable amount of time, then this is a binary search. For example, if you do half of this in a binary search, right? Then now, if the max element is bigger than both those elements, then okay, this is a good half. So that means that we're going to see whether we can use fewer, right? So we could do a half, this half. Or if the max is smaller, then maybe, you try something bigger, right? Try to see, and you could do this in a number of ways, actually, because that the max is down here. So then you could actually even just search for this one if you like. So you can actually kind of do different binary searches, but the idea here is still going to be binary search of trying to figure out how far you have to go, right? So you try, let's say you have 1,000 elements to the right. You're trying, okay, if I go 500 steps, will I be at a good building? Or 750 steps, that would be a good building. 625 and so forth, right? So kind of that idea. So that's binary search. That's segment tree. Because with segment tree, and again, I'm not going over it. My apologies. I'll show you the code in a little bit, the way that I wrote it. But I'm not going over that solution today. That's all I'm going to go over, because I think if you already know segment tree, then this is a max segment tree, and with that binary search, it is way easy to write if you already know those components, and then you just binary search on the thing, and it just becomes a very simple binary search problem, right? Let's say you don't know segment tree and you could still solve, or you want to solve this problem and you still want to, then this is what I did afterwards. I did get a hint after the contest because I already solved it. I didn't realize that there's an easier solution. The thing to notice for these problems, or one of the things to notice for these problems, is that you can cheat a little bit. And what I mean by that is that, okay, so given these queries, you can actually pre-process them in a way such that you don't have to get, like, they're fake, what I like to call fake live queries, because they're not actually live queries. You don't have to do them one at a time. You could, because you're given all the queries, you could batch them up in a way and remix them in a way such that you get the answer when you need it, right? And that's basically the way that I did this one the second time, even though I did coding a little bit terrible. I'm going to reuse this a little bit. Hang on. right? The idea is that, okay, and you could go in any direction, but let's say you're going from here. Well, let's say you have, I'm going to change up the colors real quick. So let's say you have queries, and I'm going to pair queries up with the same color. So let's say you have the red query, you have the blue query. Did I say curry? Man, I am a little bit hungry, but I meant query, not curry. Huh. Yeah, okay. I guess at least, okay. I don't know anymore. I am hungry though. But yeah, so let's say you have another green one, and they could overlap, right? So behind this problem, the idea is that when you process them, the first arrow that you see of a query, you know what you're looking for, right? Because basically, let's say you look at the blue one, which is the first one here. Oh, that's not the same blue. The blue one, which is the same first query here that you encounter, and of course you just keep track of the queries, the indexes, so that you can return them in the same order. But here, you know that what you're searching for is this number or this number, with some edge cases, but that's the idea, right? You're looking at the big of these. You're trying to find something that's bigger than these two numbers to the right. And of course, this actually is just, this is, as it turns out, is a monostack problem, because this relates to basically keeping numbers that you are able to. So the idea behind monostack problems is that the loop invariant, the invariant of every loop, is that you're keeping only solutions, or sorry, you only keeping indexes that can possibly be a solution. And because you only pop and remove once, because if you remove something from being a possible solution, it can never be a solution again. So it becomes O of n in that way. And for example, let's say we solved this query, we got rid of blue, right? I'm gonna write an X, and now we want to pre-process the blue thing, right? The blue thing, well, what does it mean, right? Let's say the next number is gonna be this number. Let's say we have a query that maybe need this number, maybe we don't, but let's say the number is this number, this height, right? Well, what happens? Well, the idea behind monostack is just that you have a stack, because now you're looking, when you process the blue number, well, this number can never be an answer. This height can never be an answer, right? Because whatever to the left of it, well, in a visual way, if for every number that is less than this blue number, well, the blue number is going to be the answer, right? Otherwise, if it's higher, then, well, the blue number is not going to be the answer, but also these will never be the answer anyway, because by definition, they're less than blue. So from there, you can kind of build a stack up of numbers that are in that way. And based off that, and I am going a little bit fast on this particular part. I apologize. There are a lot of monostack problems on Leetcode, so definitely, and I have videos on them. I don't know if I go over them any better, but definitely show up on your monostack problems, right? Before kind of going forward, because I think if you don't have a good understanding of this particular part on monostack, the second part is going to be tricky to understand why. Because the way that I think about monostack problems is that it's, so if you kind of look at this in this way, this is going to be monotonically increasing, right? Because, by definition, if this is a possible answer, then the only other possible answers that are, afterwards to the right of it, it's going to be numbers that are bigger, right? And you could kind of do that in an induction kind of way, right? So that, let me change the color real quick. So that, let's say we have this orange thing, the only other possible answers could be other orange answers, right? That are bigger. So because in an induction way, the only way that to the right is going to be bigger, then the next number is going to be bigger, and so forth. So in that way, and I did a dance move over here apparently, but so in that way, it is going to be monotonically increasing. So what does that mean for us, right? Well, what that means for us is now, let's say we have this, in an isolation, a monostack structure. So now, well, if it's monotonically increasing, what does that mean? That means that we can use binary search. So then, and again, here going back to the brew arrow for a second, this one, now we're searching for these two numbers, right? And now we have a monotonically increasing array. And so all that's left to do is we have to search for, well, the bigger number, +1 or something like this, depending on some edge cases like I talked about. But that's pretty much it. You binary search, you find the next index that is at least this number, and then that's your answer. So that's basically the idea behind this problem. It's hard, right? It's not easy. I know that, and I know that I'm going a little bit fast, but like I said, you have to understand monostack and how the monotonically increasing idea comes about. And then once you realize that you have a mono increasing stack, then everything else kind of falls into place a little bit. But you have to understand the foundation first. Anyway, so from that, I'll just go over the code. I'll also go over the segment tree code afterwards, if I remember. But yeah, but basically here, the way that I did my indexing is a little bit weird because I just kind of reversed the index so that I don't have to think about, I don't know. So I'm going left to right, so I don't have to think about, different things. Yeah, so you have N and you have Q, you have, my infinity is a little bit low. But I guess I don't really use it. I think I needed it initially and I took it out. Okay, fine. But yeah, I reverse it. You don't have to reverse it, but that's the way I did it. And because I reversed it, I have to re-index everything. And I just kind of create defense so that when we get to, so this is basically saying the defense that when we get to A, and A is the earlier one that we see. Is it? Yeah. If A is greater than B, then we swap. So A is the smaller number, but because the smaller numbers after we swap, yeah. So basically, it's because we're going from left to right. This is the first number we see. We want to do a search for with B in mind. Though you can also you could have also just put in the number already. But yeah, I wrote my own bisect left. There was a bug, so I don't know if I recommend it. Oh, geez, excuse me. Anyway, and then yeah, and this is the monostack part. So we have an answer query. Basically the lookup has all the queries anyway. So then now we have a stack thing, right? Yeah, we have a stack thing. So we pop. Otherwise, if the current height that we're seeing is going to be greater than or equal to stack, because if they're the same, again, the way that I think about handling sameness is, well, if it's the same, can it ever be an answer in the future? The answer is no, because the current index will be close anyway. So that's why you pop them. And then I append the height and the index. And then there are a couple of edge cases. If they're the same index, just set it to I and then continue so you don't have to search. If they can meet at I, and of course I is the one on the left, or the one that you see earlier, we set it to I and then we continue because I doesn't have to move, or the person at I doesn't have to move, but the J can just move to I. So then it allows heights to be equal to exactly. Otherwise, it's always max equal to 1. And you can think about this as a black box if I implement it correctly. But I do a binary search on this height, and we're trying to get the next height. And in this case, my array is actually reversed. So maybe I should just reverse the array and use I don't know. But yeah, but you do a binary search on this, and then if the index is good, then you set it to the index. Otherwise, you set it to -1 because it's not possible. and then at the end I flip them again back because we reversed it. So now we reverse it. So yeah, what's the complexity here, right? There's the reverse. This is so that's linear. This is linear. Binary search is log n, which we'll get to in a second. And then for each n, we do all these things. But for each query, we have a bisect left, which is log n. So this is going to be in total O of n plus q log n, right? Time and O of n plus q space. And yeah, that's what I have for this one. Let me show you the top. Yeah. And then let me show you the bottom. And that's what I have with this solution. Let me show you the segment tree solution real quick. And that's why I actually did it, I think, faster with the segment tree. Or very close anyway. Maybe that's not true. Let's see, how did I get to? Okay, fine. I guess I timed out. So maybe I should have had it ready. Sorry, friends. Hang on. Let me show you the segment tree solution. Yeah, a lot of wrong answers. Oh, this is in C++. I'll show you the Python one, but basically I just converted from Python to C++ and it worked. So I don't know. But this is the Python one, the segment tree. This is a very standard segment tree. So I'm gonna actually just paste it here so that it's easier to read. So I'm not gonna go over the segment tree, like I said, but this is just max. It's a max segment tree. I'm not gonna go over it. You should read up on it if you're interested. Not going. I mean, it's I don't know. I'm not a fan of segment trees, I'm not a fan of them for the purpose of Leetcode, and because I don't think it comes up on interviews. If you're in India or China, okay, but I'm not gonna get into all that. But yeah, it becomes pretty straightforward after that, right? Like we said, so we update the segment tree of each one. You could have actually just built it, but yeah. And then after that, for each query, all we have to do. So this is very similar to the other code, with just like edge cases of A and B. The height is big, just move to A, right? Otherwise, it's just a binary search. You binary search on the segment tree, and that's it. And you just make sure that your segment tree actually has the answer, and that's the idea. So what's the complexity here, right? Well, so this good function, what is the good function called, right? So the good function actually takes log n. This is segment tree stuff, so I'm not gonna get into it, but trust me, it's log n. So that means that this function is log n, but this while loop is also log n, right? So this means that this is going to be O of n plus q times log n times log n, or I know it's log square n, but I don't know how to write it in a way that is usually read. So you say it that way. And yeah, this is time and O of n plus q space. And that's pretty much it. Again, I'll show you the segment tree real quick. The setup, including the good function, just to make sure that that height is going to be bigger. And then yeah, the binary search and the query and the special cases. And that's all I have for this one. I'm really hungry, so I'm gonna go get food. Let me know what you think. And you could watch. So I have two live portions of this. One is me doing it with the quote unquote the good solution, the monostack solution. And then after that, you could see me doing the actual contest where I just kind of do the segment tree. You could skip ahead as you like. Let me know what you think, and yeah, leave it in the comments. See ya. Yeah, so this is a remixed version. So after I did this one with seg tree during the contest. In the past, it's fine or fine enough, but I think one thing, I don't know. After a brief kind of scan, someone in my Discord, which you should join, mentioned that there is another solution, a more fundamental solution. So I'm going to try to find that as a bonus solving thing for Larry. The big thing about that is going to be that, and this is one thing that I actually forget a lot. It's a common thing, but I always forget, which is noting that the queries, okay. you know, queries, right? Um, they're supposed to be live, meaning you're supposed to do them one by one, but you don't always have to. Sometimes you can just pre-process the queries in a different order. I'm sometimes I remember this and sometimes I don't. So this time I did not. This is me upsolving this problem without. That's the only bit of hint that I got, and we'll see if I'm able to kind of come up with the better solution. Let's think about it, right? And this is me doing it live, so this is maybe a little bit slow, but you have the benefit of fast forwarding, and you also probably hear after the explanation anyway. So yeah, let's see. Okay, so only hint I got was that I can pre-process queries. That's something that sometimes I forget, and I did. Okay, let's see what does that mean, right? So basically, obviously, it's going to be a scanline thing with these. So let's say you process 0 and then 1, right? What am I processing? You process a 0. Is it like an overlapping thing? So let's say you pre-process 0, right? So yeah, and you're going the other way, because I think it doesn't make sense to go this way, right? So okay, so let's say you process 7. Okay, so 7 is max. That's good. It's an answer for things, right? So let's say 7 and then 2, and then 5, right? And then now let's say we go to 1. What information do I need to get an answer for 4? Well, the answer is going to be 8. So for 4, what are we doing? What are the possibilities, right? I mean, obviously, in this case, 6 is going to go through 8, and that's fine. That's good. But what if this 8 is a 5, and then 6 has to go further, right? The 4 would still see the 5. I guess we can binary search if we have an increasing sequence for the 6. But yeah, okay. So this is going to be like one of those mono queue things or mono stack things, and then you maybe binary search on the other. Okay, that makes sense. Actually, I guess that's it, right? So you pre-process it so that when you hold the right, when you see the rightmost number, you know the other query number. So then now you could just query for binary search on the mono stack or whatever it is, because it is increasing, and then you get it to n log n. So then now that means that for each query you pre-process it by the later, or in this case, yeah, the later number, because the later number is okay, yeah, okay. I think that makes sense. Okay, let's play around with this. I'm gonna do the same thing I did before though. Just waste it. Okay, so then now we have to process the queries, so that we kind of, okay, yeah. For A, B in queries, let's say if, okay, A, B is equal to n minus A minus 1, n minus B minus 1, because we have to swap. And then now we get the smallest number. So yeah. So if A is bigger than B, then we swap. I also did that in the other thing. We'll do some like cheating things for now. No. That's different. Okay, so then now we know A is smaller. So then we have to do lookup, maybe co-everything lookup B, and then index. We need an index to kind of reconstruct the answer. Okay. Okay, yeah. Right. And then now Okay, now then for I in range of n, right? So then now we're looking up, okay, what queries are affected by this? So lookup of, so A is going to be the smaller number, so then it's going to be, so for J index in lookup, right? So J is the other number. So then now we have to binary search on this, on the increasing stack, right? Is it stack? Yes, a stack, because you're always, yeah, because you always pop and remove from the same direction. Okay, so you have a stack, is right? So then now, well, we can push on the stack. Heights sub I, and then, but before that, we remove any numbers that's smaller. So while length of stack is greater than 0 and stack of -1, the top of the stack, if it's equal, you also remove because the current number would be the leftmost. Yes, okay. Right, and then now we can do the binary search on the stack because it's is it increasing? No, no, it's decreasing actually. Yeah, that's kind of annoying. Which bisect? Is there a bisect reverse? Maybe I'm. Okay, so. And I don't know. I'm trying to think whether it makes more sense to do. I mean, it's fine. Okay, and then now we could binary search on it, but it's a little bit yucky. Okay, so then now, this, yeah, this is the query index. Let's go Q index just in case I messed that up. And then now we want to binary search the biggest number. So stack. So bisect left. We want to search for, I guess, the right. Oops. Oh, I guess just max. Why you don't overcomplicate things. So max of heights of I and heights of J. So as long as it's, no, I always forget. I guess there's that like weird edge case, right? Of can you go to okay, this is fine except for now the negatives, so you have to do something like just to kind of, I know the sign switch, but I don't know, this is gonna be a mess, but okay, so basically this is if they can if they can meet at I, then just meet at I, right? And that means that if heights of I is greater than heights of J, then we don't have to look at the stack because that's the top item on the stack anyway. But that's only case because pencil sub Q index is equal to I. Let's say I, and then we just kind of swap everything later. Because I think I don't want to think about more indexing stuff. And then continue. Otherwise, we bisect on the max, plus, and it's going to be, let's just put +1 and then bisect left. Right, and then negative infinity. Right, so then now, stack index is equal to this. Right, if stack index is less than the length of stack, then we're good. Otherwise, no bueno. Right, if we're good, then we just get the yep, answer q index is equal to stack index, the first element. Yeah, something like this. I mean, maybe off by 1 or something, but I think this is it. Maybe not close at all, but you know, you can try. Oh, because there's a lot of like random negative stuff. That's probably why. So this is max of this. So we want the negative this. Is that good enough? No. Oh, we did say that we want to swap it back though. This is concerning, and we didn't really change it. But for x for I in range of q, n sub I is equal to n minus n sub I minus 1 if this is greater than or equal to 0. Otherwise, it's just -1, I guess. Still wrong though, because we have an answer for some of these. Huh? How did that happen? Wasn't that looking okay before? Or did I just... If they're the same, what happens, right? Oh, I guess, no, that doesn't make sense. Okay, well, if I is equal to j as well, then, no, if heights is, yeah, if I is equal to j, is equal to I, continue, right? Yeah. But, I think the idea is right, but my coding is sketch. So then the negative, this +1 is kind of weird because of, I just do bisect right, so I don't have to worry. Do I? I don't know. I think this is slightly better, maybe. But it's still wrong though. Why? Tell me why. Let's look at the stack at every step. So guys, so -7 0, okay. -2. Oh, yeah. Why is the 2 popping the 7? Did I get the sign? I got the signs wrong anyway. Okay, I mean, okay, I want this, but then I want the top of the stack is smaller, then we pop. Okay. Yeah, it's still wrong, but maybe it's slightly less wrong. I don't know. Okay, so then this, 5 should pop the 2 for sure. So this is just not popping then. Why? Oh, the height is not negative. So so many. That's what I mean by like all these mistakes. It's just like very scary. To when you do just so that you can do a bisect left. Maybe I should just win the binary search. But okay, fine. Why is this still giving me an answer? Wrong answer, I mean. Let's print this and print the answer. Why just something silly? Oh, 2 answers for. Okay, no, I mean, it looks okay. So 0, 1, 2, 3, 4. Okay, so this 4, right? It updates. These 2, why? Okay, so 4, so it updates for 3 and for 2. For 3, 0, 1, 2, 3, 4. For 3, this is a 5, right? So it goes to 7, which is maybe good. I don't know. I mean, it finds the 0, so I think that's No, it finds the 1. The bisect right is a little bit weird, I think. Because now, what was it searching for? It's searching for a -5. And -5 will go to this index. Okay. Yeah, this binary search thing is just confusing. Okay, let's reset and just write our own binary search. I think this was confusing for long enough. Okay, right. So now we want say this, right? Okay. T for tuple. Okay. And we only care about it. It should be distinct anyway, so it shouldn't matter. So okay. So left is equal to 0. Right is equal to length of stack -1. Right. Maybe this is fine actually. Okay, if stack of mid with the first element is greater than, I guess we don't even need to do it this funky way. I can just do this because I'm writing it. I have the power. Okay, so if this is greater than t, this is greater than t, then mid is possibly in the answer, and we want to try, okay, so it's decreasing. If this is greater than t, then we want to try a smaller answer, is that right? Yeah. Or something closer rather, not smaller. No, wait. Yeah, no, this is fine. If it's bigger, then actually, no, we want to go to the right because we want to try a smaller number. So, okay, yeah. And then we turn left. Maybe. Hopefully no silly miss. Alright. Mostly okay. I forget to return. I don't do well with the -1s. Why not? I thought this would actually give me, this thing, but I should have stayed the same. Okay, and then now if stack of left of 0 is less than t, return left +1. Maybe that would be good enough. Okay, nope. What? Huh? Okay, so I have 7. I'm searching for 2. 2, we find the 2, right? Oh, no, we're searching for 7, right? Oh, no, we're searching for, what was it, 8, right? So 8, the stack is going to be small. Oh, this is, oh, okay. So it's actually, we return -1. Because this is actually before the first element, right? Yeah. Okay, but am I confident? I don't even know. Why am I not confident about binary search anymore? I'm so bad today. All right, let's give it a submit. Oh, yeah, the -1 issue. I don't know how to handle it quite well, apparently. I thought we popped these though. Okay, let's see. So and now we have a 2, right? So when am I fixing, so what are these queries? So the first 5, or the first 6 is whatever, and then I can't believe I'm failing on binary search. The idea is pretty okay, but yeah. Right, let's see. First 6 is that, and then is 1 0 1 1 1 2 1 2. I'm getting 1 2 wrong. 1 2 is 1 and 2, right? So then the next number is going to be not possible. I put 3 because it's equal. Why? So this is the stack. This is the stack, and then we search for. Maybe my thing is wrong. No, I mean why? Tell me why. Tell me why. So I have this, and then I search, and it gives me these. What am I searching for? Oh, did I forget? Oh no. I meant to do a +1, and then I just forgot about it, and then I implemented that way. Oh no. How did that happen? Is this right? Okay, I think this is right. I implemented it as a bisect left. I mean, this is good separation, but then I just forgot that I need the next number. Oh man. And there are a lot of technical difficulties even in this resolve, even knowing how to do it. So that's or figuring out the idea pretty quickly. Okay, what am I doing? So 0 1 0 1. The next number should be 2, which is a 3. Why is it giving 3? Man, I don't know how to binary search. Maybe I guess that's it, right? How am I failing this? Okay, 4 0 3 1. Oh, excuse me. Oh man. Okay. All right. So this is a 3. So I keep a 1, even though this should be. No, I mean. Oh no, this is the wrong one. Okay, so 2 1, right? So then now you pass the 1. It gives us 0 for some reason. Even though that should be. Wait, what are we binary searching for? So we have a 1 and a 2, so we should be binary searching for. Did I do the indexing 1 anywhere? We should be searching for a 3, right? Oh, I think I have to. Okay, fine. I did do the binary bisect left wrong. I guess I don't know how to binary search apparently. Sorry, friends. But hopefully, you know, like 2 people watching. All right, let's go. All right. That's not. I mean, the algorithm I think is pretty okay. Unfortunately, the implementation again is left much to be desired. Yeah, I mean, I'm gonna go over this in the going over section, which you always watch. So I'm gonna do it there. Yeah, and I think next I'm gonna show you my live during the contest. So yeah, I mean that's a very silly mistake, but also, how do people do it without? Like I don't know. That's really tough. I don't know. That's a very silly mistake. Okay, I take it back. I have made a lot of silly mistakes. How bad am I doing? 163 is not that bad. People actually struggle with Q3. Okay, but people solve Q4 in 5 minutes. Let's give it a try. I don't know if I could do it, but well, definitely not 5 minutes. But we could probably do fast. All right, heights of positive integers, heights of I. And move to any other building J if and only if I is J. Okay, and okay, so basically they can move from left to right to a higher building, I guess. Okay, you're given another query. 0 and 1 is the index. Return array answer. Answer is the left common building. Okay, let's see. Kind of get the idea, but okay, from 0 and 1, so they're both here. They can both just move to 2, right? Okay. Alice and Bob can move to, what was the thing? 0 and 3, so 6, and then 0, 1, 2, 3, and then they could both move to the last one, right? Okay. The third one is 2 and 4, 2 and 4, no bueno. Building 5, 3 and 4, 0, 1, 2, 3, 4. Yeah, okay, same thing, okay. Fifth query, they're on the same building, okay. Okay, how do I do this? So, okay, so basically you want a number that's bigger than both of them to the right of some index, right? Can I do a binary search? Like so this is good. So we want to reverse it and then prefix it. I mean, there is going. I mean, you could do a binary index tree with the prefix, and then what is that? Is it log square n? What is the complexity here? Is that fast enough? N log square n. What's log square? What's it? 5 times 10 to the 4th. What is that? 10 of 16 or 2 to the 16? Right? A little bit. 16. So 16 square. 16 square is fine, right? Well, but the complex, it's a tough. Is it the easiest? I don't know. I could see. I mean, that would be a way to get in like 5 minutes, though. Is there a similar way? I don't know. All right, let me let me cheat and pull out my template for binary index tree. Where's my binary? I think I used it like last week or maybe the week before. I wonder if this is just an inherent segment tree one, but so okay. So what does a binary tree look? I don't. Oh, I do have it. Okay, fine. And we want a max one, which is actually literally what we did last week or 2 weeks ago, maybe, right? So I kind of remember how to do it. So it's not increase anymore, it's set. Update, I think. So update. How did I do it? I think I got it, but I don't want to make a mistake. I'm looking at my thing from last week. Because that was literally a last week thing, right? What was it? Was it that one? Maybe 2 weeks ago. These weeks are running together now. Okay. I mean, I guess so. I guess this should be fine. I was worried that I think this is actually inaccurate. That's why I'm a little bit weird that I'm looking at my code from the last time, but and Yeah, and I thought that I think this is technically not, like, this update is technically wrong because this only works if it updates upwards. But in any case, I guess it doesn't matter for this problem either. So okay. Yep. I think n is fine. I don't need to do like a. All right. Wait. No, that's right. That's right. Should be good. And this is get max, I think. Oh, wait, this is per query, not, okay, fine. So for AB, is A always less than B? Nope. Okay, whatever, we'll do it. And then now A is less than B. Answer array. Yeah, I'm just lazy. It is do then A continue. Otherwise, left is 0, 0, right is 0, 2. A minus 1 because we want to keep it inclusive. If okay, so if this number contains the max, or if it can, then we want to try to look. Is this right? No, am I doing something silly? So it already contains it. No, I'm doing it wrong. This isn't quite right, is it? Because we want, it's not just a prefix. Prefix isn't good enough. Because we want the leftmost, so that means we want the rightmost. What was I? So you want like so you want a segment, a max segment? Do we need segment tree? Is that going to be even fast enough? I mean, it's still going to be fast. How many queries do we get? We have a lot of queries. But I don't know if it's going to be fast enough with all the stuff. There are no updates. I guess that's good. Binary search. Yeah, I mean, I think that's it, I guess. This is good. If the middle chunk contains thing, then you want to go to the right. So that means that left is equal to mid. Right, else right is equal to mid minus 1. Rest of that's no good. Wait, what? No, that's not right. Is it? Okay, so you try from A to mid. So if that's good, you go to the right. Otherwise, you have to go more to the left. Okay, no, that's right. But is it mid or mid minus 1? Well, mid could no be good, so right. and then if and that's good, and then we check left if height sub left is greater than or equal to, no, it has to be strictly greater than height sub A and height sub, well, technically I guess height sub B is fine because B is, oh wait, no, we didn't do it that way. And this is like n minus 1 or something because we reversed it. And I think we can actually just do this really quickly. Now, we should be able to do it that way, from 0 to whatever. But I'm not gonna do it that way though. Fine. Well, we'll keep it this way for now. If we need an optimization, then we'll you know. And the sad thing is that this is mostly done. It's just that we have to kind of do the segment tree part, which is like, I mean, I guess people have optimization or have a pre-written code for this, which makes it much quicker to do this. I have one as well, but I don't feel good using it. I don't even know if it's gonna be right. So let's see. Good thing is you don't need to do lazy. So, and this is all. Oh, I already have a max seg tree. That's actually very convenient. Well, my default seg tree combo is max. Probably not a good idea, to be honest, but okay, fine, because I don't think that's less common, I think. But update how do I always forget how to do this actually. We don't even use the build. Oh. Whatever. I don't think it matters that much. Okay, fine. I'm just going to quit. I forget how to use update. I always do. I think it's 0 and n minus 1. But okay, and then now to define the good function. This is exclusive. Let's make it inclusive. Then if max, if st.max I minus 1, left right is if this contains a number greater than height sub A. Yeah, whatever, okay, fine. And yeah. I mean, I think this is conceptually right. There's a lot of possible wrong things like this, but update I to height 5. Okay, fine. Oh, is it 1 and n? I always forget the notation. Huh. Now I'm missing something. I don't even know. I gotta have an example how to use this. Hmm. What is I? If this is not I should forget what I is. Well, I did it twice. That's a little bit weird, right? I think this is just one. All right. Well, I mean, at least it returned something. Not even the right ones. Yikes. Why is this wrong? Tell me why. Oh, this isn't right. That's why I wrote it in a weird way. But okay, so if m is equal to left left and a minus 1, yep. That's why I kind of wrote it, changed it back to writing it this way, but and we made timeout, and apparently memory limit exceeded. How can the memory limit exceed it? It's just 4 times. If only I used C++ or something. What am I going to do? Limit exceeded for this input. Maybe I'm Stack Overflowing then. That doesn't make sense otherwise. Man, I gotta remember how to use these things. This is so silly. But I don't. What is this? What is I? I is the. What is position? Did I mess this up? Is this I and this is 1? Oh, that other one makes no sense now. Okay, at least that's good. It's giving me an error. What is I? I is the node, so it should be 1, right? Or 0? No, 0 doesn't make sense, does it? Yeah, alright, let's just return true. I want to see if it's the update that's giving me issues. Yeah, so it's update that's giving me an issue. So I'm just don't know how. Man, I don't use segment tree enough. You know, maybe just as much as I need to be, but I is definitely 1. Is the other stuff wrong? 0 minus 1. Position is I. Okay. That's not. That's not good. Did I mess something up? How can this give me memory limited? Like I literally don't do anything anymore. except for this. N plus, what is N? N is just like 6. I'm doing some funky things. Tell me why. How much time do I even have left? 44 minutes. I'm okay on time, or at least in terms of for completing. For rankings, probably not so good. This is so silly. Like, I'm just debugging a template, right? Like, I'm not even debugging anything real. Oh, maybe that max thing was kind of doing something funky actually. But okay, fine. So even this is returning true. Or even just returning true because of this thing, maybe? I have so many, like, okay. So max is definitely a little bit funky right now. So max, I feel like I got the things right. Yeah, I think this bounce should be right for max. So why is it giving me oh. Oh, I will pass it, but it should be continued. Okay, this should do nothing. Okay, good. And then now I want to put this back in. Okay, that's good, I guess, right? So max is the one having issues. Okay, well, even just one of these. Yep, okay. Then even just one of these is good enough to, okay, so we're having some issues with max, even though I thought the thing should be fine. Maybe it is just from 0 to n minus 1. I'm just like being silly. I forget which, like one of, it's really weird because some of these are not one index and some of these are not one index. Now I always forget which one is which. Okay, so basically we're back to the beginning where the answers are actually so wrong, but yeah, I got the 2 right, so I mean that, I think that's just base case, but 0 and 1. Oh, because A and B are different. A, B is equal to n minus A minus 1, n minus B minus 1, that's why. Okay, 2, 5, 1. Yeah, I mean, okay. I think I have to swap them only after. Okay, so this thing has to move up, but alright. I mean, we got case 1 correct, which is good. Case 2 is wrong. Tell me why you're wrong. 0 and 7. 0, 1, 0, 1, 2, 3, 4, 5, 6, 7, 5. Okay, so clearly this should be the 6, which is, yeah, or the 7, or the 6, which is the 7th position. Oh, they can meet at itself. Okay, so that's fine. I mean, I didn't do it that way, but that's easy fix. Okay, well, not an easy fix. Thought it'd be easy. Oh, okay, I think it's this thing. And there are a couple of things like that where left and A inclusive. Okay, no, that should be right. Oh, because A doesn't have to move, so it could be just equal to. It's equal to if A doesn't have to move. Because if A has to move, then it's not equal to. Okay, I see. Okay, okay. So I think this is fine. We just now have to do another thing of if heights of A is is greater than heights of B, and just move to A. Right, so ends dot append minus A minus 1. Still worried about the timing though. All right, so this is going to be right. I could stress test it, but if it fails anyway. So, or like if it times out, even. I mean, I guess it times out, but which is, I actually don't. I mean, to be honest, I don't know whether this times out because it is Python or, because this is like on the border of that. Can I be a little bit smarter? Because the max is only. No, I mean, I think this isn't that bad. Or it shouldn't be. So, open, what's it called? Open AI, whatever. Chat GPT. Yeah. I'm going to just convert this into C++ and then, or I try and then see what happens. Where's my window? I have so many things open. Why, Larry? Why? Tell me why. Convert this to C++, please. We'll see if this works. I don't know if it works. I mean, it should be pretty straightforward because I don't think I use any crazy logic here. But we'll see if ChatGPT. This is the ChatGPT. Okay, wow, good examples. Thanks. Is the thing? Is this accurate? I guess they added STD stuff. Okay. We'll see if this works. I actually have no idea. Oh, do I still have? I do. Nice. Then I could just use this. Though I don't know what the right answer is, but I guess I mean, I could get a wrong answer, but we could test the timeout quickly. I guess if this is fine, then I actually should be able to just do this, right? I mean, it may time out, but yeah, all right. Let's give it a submit. I mean, it may be wrong. I should double check this. So this is kind of silly, but I don't know if that's the. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest, this problem, the explanation, maybe everything in between. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.